Dear all, I welcome you all for the lecture session Waste Processing Technologies. This is Dr. N. Ramesh, Professor Civil, K.S.Rangasamy College of Technology. The first one is objectives of waste processing. First one is the definition. Processing techniques are used in solid waste management systems to improve the efficiency of solid waste disposal systems, to recover resources, and to prepare materials for recovery of conversion products and energy. The next one is material processing technologies. Processing separated materials for reuse or recycling. Common techniques are shredding, compaction, baling, washing, and drying. Here, this it is a AI generated one. This diagram shows that how to minimize the wastages using the different processing. How to minimize the waste and reduce the waste. The waste are going to be compressing and the volume is reduction by the equipment, shredding equipment. Here it is shown the shredding equipment. This equipment is going to be reducing the sizes. So here that reducing the sizes means that compaction is easily, transportation also very easy. So biological conversion technologies, decomposition of organic waste using microorganisms, environmentally friendly process, types composting, aerobic, anaerobic digestion, biogas production. Here you are seeing food waste. The food waste go for the wastage food go for the anaerobic digestion. We are preparing the methane gas. The methane gas used as the fuel and then digested and then biogas production, and sometimes we are using it for the combustion the heat generation recovery, and through the biological we are using the compost as well as the power production also possible, and it is used as a fuel also. Advantages and disadvantages. Reduction in the quantity of waste materials to be handled at the disposal site. Improved efficiency of collection and disposal of waste. Increased life of landfills. Economically viable waste management systems. What are the disadvantages? The poor quality of recyclable waste material sorted out of compaction vehicle. Difficulty in segregation or sorting since the various recyclable materials are mixed and compressed in lumps. Biodegradable waste materials, example, leftover food, fruits and vegetables destroy the value of paper and plastic material. Equipment used: hydro pulper, hammer mill, chipper, grinder, shredder, jaw crusher. Here you are seeing the hydro pulper and hammer mill and shredders, which are used to reduce the quantity of wastages. Okay. Chemical conversion technologies, chemical reactions used to treat or recover energy from waste. Methods: hydrolysis, oxidation, neutralization, and chemical stabilization. Here you are seeing the raw waste and water added, and then collection sump, flash mixing, flocculator, sedimentation tank, treated water effluent is taken for the domestic network, and sludge is taken to separately, and it is taken in the sludge holding tank, which is treating the raw wastewater, and in side by side pH adjustment, and chlorine is given for the disinfection, and dosage properly monitored. Composting, biological decomposition of organic waste under controlled conditions, produces nutrient rich compost. Methods: windrow composting, aerated static pile composting, in vessel composting. Here you are seeing the windrow composting. In the windrow composting, that wastage is converted to the pulverization, raw waste, and moisture stockpiling and water sludge. The second one is raw waste is taken for the screening, stabilization, and finally taken for the usage for the composting. You are seeing the windrow composting. Controls in composting: temperature 55 to 65 degrees C, moisture content 50 to 60 degree 60 percentage, aeration, carbon nitrogen ratio, C bar in ratio. Here you are seeing that graph which is shown the various cycles, that is ammonia cycle, methane cycle, and hydrogen sulfate cycle, and hydrogen sulfate cycle 1, ammonia cycle 2, methane cycle, which is shown for the in horizontal wise days are calculated up to 41 days, which is used for the making the composting. Okay, next one. Thermal conversion technologies: high temperature treatment of waste reduces volume and recovers energy. Types: incineration, pyrolysis, and gasification. Here you are seeing the incineration as well as pyrolysis and gasification. And the line diagram is given for the incineration technology: steam boiler and air heater, and finally it is go for the rotating the turbine, and finally it go for the cooling tower, and taken for the energy. Okay, next one. Energy recovery from waste: conversion of waste into usable energy reduces dependency on fossil fuel. So we are using the fossil fuel day by day. We know it creates a lot of pollution problem. So we are in need of alternative energy. This type of energy recovery, which gives the waste to energy concepts. Forms of energy: electricity, heat, biogas. Here that diagram which shows how to convert the waste into energy. Incineration: controlled combustion of waste at high temperature reduces waste volume by 70 to 90 percentage. Advantages: rapid waste destruction, energy recovery. Disadvantages: air pollution if not properly controlled, and high capital cost. Which are the advantages and disadvantages if we are go for the incineration? So few advantages are there, few disadvantages are there. We have to select which technology is appropriately used for the according to the wastage which is produced in the community. So here you see the waste delivery and incineration technology, flue gas cleaning, and energy recovery. So more than 21 parts are there: the tipping hall, waste bunker, waste crane, waste feeding chute. It is clearly given in the figure: ram feeder, incineration crate, primary air fan, bottom ash bunker, bottom ash crane, secondary air fan, steam boiler, boiler safety valve, flue gas reactor, hydrated lime, activated carbon, back filter, residue silo, ID fan, emissions as monitoring systems, CEMS stack, and energy recovery, steam turbine or generator, which are shown in the diagram very clearly as part by part, one by one. Solidification and stabilization of hazardous waste reduces mobility and toxicity of hazardous waste. Solidification: addition of binding agents, cement, lime, converts waste into solid form. Stabilization: chemical reactions reduce toxicity. So it is the how we are going to take the waste. It's a construction and demolition waste is shown in the diagram, which is also used for the recycling or landfilling or used for some other purpose. Treatment of biomedical waste: special treatment due to infectious nature. Methods: incineration, autoclaving, microwaving, and chemical disinfection. Medical waste generation: source segregation, regular waste, sharp waste, pathological waste, pharmaceutical waste, radioactive waste. Collection and transport from hospital to storage: regular storage facilities for sharp and regular waste, storage with temperature maintenance for pathological and pharmaceutical, storage facilities, radioactive waste, storage time based offline, incineration or autoclaving, 3PL vendors and hiring and administration, which is shown in the diagram very clearly. Thank you for watching.